Suppose the lengths of pregnancies of a certain animal are approximately normally distributed with a mean of 221 days and a standard deviation of 19 days. The first part of this question says, what is the probability that a randomly selected pregnancy lasts less than 214 days? So because we're told that the original distribution is approximately normal, we can answer this using the normal calculator within StatCrunch. So I'm going to go to Question Help and open StatCrunch. And specifically, we're going to go into the normal calculator. So go Stat, Calculators, and select Normal. What we're going to do is put in the mean of 221 with the standard deviation of 19. To say that one that is randomly selected has a pregnancy less than 214 days means we want to make sure the less than is selected, and we put 214 here, and by clicking compute, we get the corresponding probability. So for one chosen at random, that's 0.3563 if I round to 4 decimal places. 0.3563. So what does this mean if we chose 100 at random? So we would take this 100, multiply it to the given probability, and it will move the decimal point over 2 places to 35.6. If we round that to the nearest integer, we're going to get 36. So we're talking about, less than 214 days. So in a sample of 100, we'd expect, about 36 of those pregnancies to last less than 214 days. That is the interpretation of this probability. But it goes on to say, well, that's if we just selected one at random. But what if we chose 21 at random and looked at the mean of those 21? Could we ask a similar question about the probability? If you want to use the normal distribution to do so, you'd have to know that the sampling distribution is itself normal. Because we started with a normal distribution, it is a fact that the same must be true for the sampling distribution. You need the mean, and you need the standard deviation, which if we need to, we'll round to 4 decimal places. It turns out that the mean for this distribution will equal the one that we started with. That will always be true. But the standard deviation is not going to be exactly equal to this. You have to take this number and divide by the square root of your sample size. I'm going to use a calculator to figure that out. I'm going to do 19 divided by the square root of 21. So that number, let's see, that is 19 for my standard deviation. I'll divide by, I'm going to open a parenthesis, because I'm first going to put in 21 and then take the square root of that number. That's the square root of 21, which I'll close, and I'll hit equal to divide that into the original standard deviation. So if we round it to 4 decimal places, that's 4.1461. 4.1461. Okay, great. With this information, we can now use StatCrunch to figure out the probability that the mean of these pregnancies will last less than 214 days, or is less than 214 days. So we're going to go to StatCrunch. I'm going to leave the mean alone, but for the standard deviation, I'm going to put in 4.1461. I'm going to leave the less than and the 214 alone. And if I click compute, this is the new probability. And if I round that to 4 decimal places, you get 0.0457. So 0.457. So that dropped dramatically. It went from this 0.35 to a 0.04. But that makes sense. This number should decrease if we're talking about a sample of size 21. Similar question here where Well, if we multiplied this by 100, we're going to get, if we move the decimal point 2 places, you would get 4.5. This 5 rounds the 4 up to a 5. So I'm going to choose, okay, again, we're talking about 214 days or less. So in a sample, 100 independent random samples of size 21, we'd expect about 5 of those to have a mean less than 214 days. So this question goes on. It's like we started by selecting 1 at random. Then we selected a size of 21. Well, what if we went even further and said, well, what if we chose a sample size of 52? Again, I would expect this probability to drop even more. So we're kind of like jumping to the part of, we're going to go directly to StatCrunch, put in the proper mean, whatever the new standard deviation is, to figure out this new probability. Well, for starters, we need the standard deviation. At this time, we're going to take 19, and we're going to divide by the square root of 52. So that is 19 divided by, and we'll do 52 and take its square root and close the parenthesis. I'll hit equals. So this is the new standard deviation, 2.6348. So 2.6348. We're leaving the mean alone, but we're still asking about less than 214 days for the length of the pregnancy. All right, and yeah, this dropped even further to, if we round to 4 decimal places, 0.0039. So 0.0039. And what would our interpretation be? Well, if you multiply this by 100 and round, it would actually be 0. In a sample, if you took 100 independent random samples of size 52, you would expect about none of those to have a mean less than 214 days. So again, we're looking for the less than, which is this, and I'm going to put in 0. All right, so to complete this, part E is saying, well, what if you did this? You did select 50. You found 52 individuals that you selected and took their mean, and it turned out that mean was less than 214 days. I mean, first of all, this is very unusual. It's less than 5% by a lot. So, I mean, this result would be unexpected. It is unusual. So, I mean, you could conclude that since it happened, maybe there's something wrong about your original mean and standard deviation. So it's probably that the original population mean, was not 221 days. It was probably something less than that. And for the last part of this question, okay, what is the probability a random sample size 17 will have a mean gestation period with 11 days of the mean? So we already have some of the information that we need for this question up here. I guess I'm going to first figure out a standard deviation. And I'm going to take 19 and divide by the square root of 17. So I'll go back to my calculator to get this number. So for my standard deviation, that was 19 divided by, and we're dividing by the square root of 17. And that is 4.6082. 4.6082. Just want to double check that. Okay. And, okay, we're going to leave the mean alone, but we're still saying, well, this is different actually. Each part of this question was, we're less than 214 days. But now the question is saying, well, what if you're within 11 days of the mean? So we have to now choose the between, because to be within 11 days of this mean means you can be 11 above it and also 11 below it. So if we select 221 and go 11 below it, I'm going to take 221, subtract 11, which is 210. If I do 11 above it, I will add 11 to 221, which is 232, and I'll get the probability, which is quite high. I mean, that is not unusual that it would be that large, but the value is 0.9830. Okay, so about 98%. Okay, that is everything for this question.